Hello, my name is John Clifford. I'm a senior fellow at Construx and the Agile Practices Lead, and this is one of a continuing series of lectures on my 7 steps to project success. Today I want to focus on step 3. Make realistic plans based upon accurate estimates, but make realistic commitments based upon demonstrated performance for activities. What do we mean by that? We should plan with our estimates, but we should track with our accomplishments. The way we do this in the Agile world, particularly for running Scrum, is we use a release burndown chart. So what does a release burndown chart show us? It shows us progress to date, and we can use that progress to date to forecast project completion dates. Now, the beautiful thing about an Agile approach such as Scrum is that it lets us gather a lot of good historical data on our current project while the project's in flight. And as you know, historical data on your current project is the gold standard for predicting project completions. So let's talk about the release burndown chart for just a second. This chart is simply a bar chart showing the amount of scope that remains to be implemented from at the beginning of each sprint. So if you look at the bar chart we're showing, at the beginning of sprint 1, we have a little over 500 points of scope in the project. Let's ignore the red scope right now, the scope that shows up below the x-axis, just for purposes of discussion and explanation. So as you can see, at the beginning of sprint 2, we have about, 420 points of remaining original scope? So the difference between the height of the two bars, the delta, is the amount of scope that was implemented during the first sprint. So it was about 80 points we got done during the first sprint. Now this again is a simple chart, but it shows you that we're averaging about 80 points a sprint, so that given that 80 points per sprint velocity, we would be done when we have no more scope left at the beginning of a sprint. And if you look at our chart, it shows that somewhere around the end of the 6th sprint, give or take, we'll have no scope left. Now we can calculate that exactly by using the numbers, but the chart itself gives us a pretty good trend that we can use to forecast with our eyeballs. So we call the change in scope, the difference between the scope that was implemented during a sprint, we call that team velocity, or the rate at which the team can implement scope over time. And we would express that in terms of story points per sprint. So now let's look at the red bars under the x-axis. What does that mean? Well, if you work in the real world on projects, you know that there's always going to be scope added to a project once it starts. Not because scope necessarily changes, but perhaps because our understanding of what the customer really wants changes. So when we add scope to a chart, we add it to the bottom, just as when we implemented scope, we took it off the top of the bar. So again, the amount of scope on the bottom of that bar in red is the total scope from the start of the project to the beginning of that sprint. So we can see that during sprint 1, we added about 50 points of scope, and that's why we have that chunk of red under the bar for sprint 2. Now between sprint 2 and sprint 3, it doesn't look like we added any scope, but we added some scope between sprint 3 and sprint 4 during sprint 3, and that's why the bar at sprint 4 is lower than the bottom of the bar at sprint 3. We added a little more at sprint 5 and maybe a little more at sprint 6. So what this effectively does is it pushes the x-axis down. So if we don't add any more scope, when will we now be done with the project, considering we had the original scope and all of this new scope? Well, if we project the team velocity line out further, we can see it'd be somewhere around the end of the 7th sprint we would have no scope left, give or take. And again, we can calculate that by looking at the team velocity and also looking at the scope velocity. So scope velocity is the rate at which we're adding scope to the project, again expressed in terms of story points per iteration. And so we have about 100 points added after sprint 6, so we're adding about 15 points or 16 points per sprint on average. So if we don't add any more scope, it would be about 7 sprints. But if we really were to truly draw the scope velocity line, we would have a slight downward slope to it, which would show us it would be somewhere around 8 sprints when we would be done. The beautiful thing about a release burndown chart drawn in this fashion is you can immediately see the impact of adding scope to your project, what it's done to your timeline. We can also use a release burndown chart, again, for being able to forecast delivery dates and scope. If we cut scope, where will we cut scope? Off the bottom of the bar. So if my product manager came to me as a product owner and said, hey, we've got the releases after the date, which would be at the end of sprint 5, because our competitor has just announced a new version and has some of our features. So what would you have to do to get out after 5 sprints? Well, again, looking at this chart, I have to run out of scope at the beginning of sprint 6 to be done in 5 sprints, which means I have to cut about 80 points of scope. Now, which 80 points I cut is a product owner decision driven by the stakeholders. But I'm going to have to cut 80 points of scope and plus all the new scope that was added. So at the end of sprint 5, we have about 100 points of new scope. I'm going to have to cut in 80 points of existing scope. So somewhere in that mix, I've got to get rid of 180 points. The beauty of this chart, again, is we can estimate all we want to in terms of our ability to get deliverables done over time or our team velocity, but the chart will show you what the real number is. So a good product owner updates his chart at the end of each sprint and can continually forecast and commit based upon the latest possible data.